This is where we left off on the discussion. I talked to you about cis and trans and about the importance of the geometry about that double bond and how we can determine which one is which. And I left you off with this question, and it says draw the cis and trans isomer, if possible, for each of the following molecules, and then we need to name them. So we need to go through and we need to kind of work through each of these, all four, and then I'm just going to take my time because I think that you need that sometimes. And if it takes up 30 minutes to do these four examples, then that's what it does. I don't care. And if you don't need all 30 minutes to watch these, then put me on double speed in YouTube and speed me up. It will get me finished in half the amount of time. So let's start with A. All right. A is CH2CH double bond CH CH2, and CH3. So the directions told me to name them, and I'm going to name this first, right? If I can name this, then the name's not going to change. The only thing that will change in the name is putting the word cis or the word trans in front of it. I mean, give me a break. That's all there is. So I'm going to name it first. 1, 2, 3, 4, 5. 5 carbons in total. So 5 carbons in total. This is called a pentene, E-N-E. There's a double bond. That's why it's an ene. If I start from the left, 1, 2, on the second carbon, there's my double bond. If I start from the right, that's going to push me at 3, and that's a higher number. That's not appropriate. Okay, so there's the name of the basic structure that we've seen up to this point most of the time. Now the question's going to tell me, I have to draw the cis and the trans if it's there. So this is how I do this. I focus in on this double bond area right there. So there's my carbon, double bond, carbon. And this carbon's got 2 bonds and that carbon has 2 bonds. This carbon to the left has 2 things attached to it. I hope you can see that. The first one is this CH3 molecule. That should be a CH3 there, not a CH2. Is a CH3 group. All right, so CH3. And then a hydrogen. There we go. The right-handed carbon has a CH2CH3 group, so I'll just put it up at the top. Whatever, I got to do both of them if they exist, so it doesn't matter. And then a hydrogen for the other group. There we go. So this is still a 2-pentene. There is no difference. It's the same molecule as what it was. How do I know? Just double check it. There's my longest carbon chain right there. My longest carbon chain is 1, 2, 3, 4, 5, still pent. It's still an ene. And at carbon number 2, that's where my double bond is still at. So it's still a 2-pentene. Now, is this really proper? Does it really have cis or trans? Well, this one has a hydrogen that points down, and this one has a hydrogen that points down. So both of these have hydrogens. They are pointed in a specific direction based on what I just drew down on a sheet of paper, what I've drawn. And those 2 hydrogens are pointed in the same direction, which means that this is a cis notation. That's how we do these, all right? So let's do the other version because it told me to do both. If it has them, do both. So I do this again, carbon, double bond, carbon. This one has 2 bonds. That one has 2 bonds. And now I'm just going to pick one side. I'm going to flip it. If I flip both sides, it gets me back to what I just did. So I just need to pick one side and I need to flip it around. All right, so I'm going to keep the left-hand side the same. I did my CH3 at the top. I'll do my CH3 at the top there still. I did the hydrogen toward the bottom. I still point it toward the bottom. Over here on the right-hand side, I did this ethyl group that was pointed up. So in this case, I'm going to do ethyl that points down. And then I've got a hydrogen that's also on that carbon, and I'll put a hydrogen there as well. So one side I flipped, and you can tell what's happened now. It's still a pentene. I can circle that. There's my longest carbon chain. 1, 2, 3, 4, 5. So this is still a pentene. I still have the double bond at carbon number 2. That does not change. And I now need to compare my hydrogens. So this hydrogen is pointed down on that carbon, and this carbon, the hydrogen's pointed up. They are pointed in opposite directions. So because of that, we call this a trans 2-pentene. And folks, this is the answer to question number 1. So we've got 3 more to go. So the normal, what we've been seeing up at the top, and then a cis form, and then a trans form. And the reason it had cis or trans is because this carbon had a hydrogen and this carbon had a hydrogen. If both of those did not have a hydrogen, we could not do this. All right. Also keep in mind that if a carbon has 2 hydrogens with a double bond, there's no way that you can compare them, because we can't have a hydrogen here and a hydrogen there and then figure out which one's which. Okay, they're equal. So there's no such thing as a cis or trans with those either. All right, so let's do part B. All right, the next one, they gave me a CH3, a CH, a double bond, and then they wrote a C with parentheses, CH3, they closed it up, and they put a 2 after it. So for some of you, this might be a little difficult to name at this point, and that's because you see this weird parentheses that happens at the very end of the structure. So let me clear that up for you. How do you want to draw that to make it a little bit better to understand on what they're trying to get across? Well, we'll do a CH3, and we'll do the CH double bond C. And what this means is that that carbon has 2 CH3 groups on it. So I could draw one straight up like this, and then I could draw the next one straight out like that. Okay, so that way it might be a little bit easier to name just as a straightforward name. We're not going to do cis or trans yet, right? I mean, we don't even know if it has cis or trans at this point, but we're just going to name it normally. So how do we name this? We do it all like we've done before. You find the longest carbon chain with the double bond. All right, so it just so happens to go all the way across. There's my longest carbon chain, 1, 2, 3, 4. So this is a butene. So that's what I'm going to write here, butene. And that butene, if I go left, happens at spot 2. And if I go from the right, it happens at spot 2. So it's going to be a 2-butene no matter what. And the other things are going to help me determine which way I do need to number this. And I have this methyl group that's right there. And this methyl group is closer to the right-hand side. And this way, that gets the methyl group the lowest number. So I need to put on the front 2-methyl, 2-butene. So there's the straightforward IUPAC name to that structure that you see there with the parentheses. And that's how you handle those parentheses. If you need to take the time to draw it out that way, like over on the right-hand side, then do that. No one's going to scream at you. No one says that you can't do that. So do it if it helps you do it. Now I need to figure out cis or trans. So I'm going to come down here below, and I'm going to focus in on these 2 carbons with the double bond. So carbon, double bond, carbon. And this carbon has 2 things on it, right? I mean, they all do. So here's the 2 bonds on each side. And I'm just going to randomly put them on there. And then I'll figure out, did I draw cis or did I draw trans? So to the left, I have a CH3 group. There we go. And then I also have a hydrogen on that carbon. So there's that one. And on the right-hand side, I have a CH3 group. I'll just point that one up. And then another CH3 group. So I'll put that one down here. So now we got to figure out, do we have cis or do we have trans? Well, just to confirm it, longest carbon chain. All right, longest carbon chain right there. There we go. 1, 2, 3, 4. It's still a butene. Carbon number 2, I still have a double bond. On carbon number 2 from the right-hand side, I still have a methyl group. I've not changed my name. It's the same structure. It should be. So I now need to figure out, did I draw the cis or did I draw the trans? All right, to the left-hand side, carbon, I have a hydrogen. It's right there. It's pointed down. On the right-hand side, carbon, well, I don't have a hydrogen, do I? This is a methyl group. And we've been comparing hydrogens all this time. I told you that each carbon needs a hydrogen. So that means we can stop here. There is no cis and there is no trans form of this molecule. And the reason is because this needed to be a hydrogen in order for me to label it this way. And there is no hydrogen at that location. It is a methyl group. It is not a simple H. So our job is now finished. We can move on to the next one. I can go on and work on example 3 because I've just determined this has no cis or trans form. It is just 2-methyl-2-butene, people. That's all you get from this one. You get no option because this does not classify as cis or trans. It might classify as something else, though. Hint, hint, hint. And that we'll learn a little bit later. But it does not classify as cis or trans. So we'll go to part 3. All right, part 3 tells me CH3, CH, double bond, CH, and CH3. So just like before, I'm going to name this sucker. 4 carbons in total. 4 carbons in total. Butene. Where does the double bond happen? It happens at number 2. Whichever way I go, from the left or from the right. Who cares? And that's really all there is on that molecule. I've taken care of everything, right? Simple, easy peasy. Ding, ding. There you go. Move on to the next. So now the directions tell me to draw the cis and the trans, if there is some. All right, so I'm going to focus in on the carbon double bond carbon area. And I'll draw carbon double bond carbon. And I know that this has to have 2 and that one has to have 2. I just now need to figure out what goes on them. All right, so this carbon to the left, it has a CH3 and a hydrogen. I don't really care how I put them on there right now, and you shouldn't either. And then to the carbon on the right, I've got another CH3 group and another hydrogen. So I'll put them there. So if I just double check my longest carbon chain, there we go. 4 in total, butene, 2 butene, because it's the second carbon in, whether it's from the left or whether it's from the right. It is a beautiful, symmetrical molecule. All right, now the carbon to the left. I have a hydrogen that points down. The carbon to the right, I have a hydrogen that points down. So this does have cis and trans. And I know that because each side has a hydrogen that I can compare. And the hydrogens point in the same direction. So this is called the cis form. And this is cis 2-butene. Now I've got to draw the other version. It tells me to do that, right? So I'm going to start here with my carbon double bond carbon and draw the legs on each one. That's how I set this process up. To the left, I just keep those the same. I don't really mess with both sides. I just do one or the other if I'm trying to represent both. And on the right-hand side, I told you that we're just going to put CH3 up on top. Well, now we'll put it at the bottom. And I'll put the hydrogen there. That flips it. Again, if you flip both, you get back to what you started with. If you double check, 4 carbons in the long chain, 1, 2, 3, 4, still a butene. It's still 2-butene. But now the hydrogens point down and 1 points up. They're in opposite directions. So this is the trans 2-butene form. And that's how we do that. All right, so example 3 is now finished. And now I'll go to example 4, the last one. So I've got CH3, CH2, CH double bond CH2. And they tell me to go through and name it and draw cis and draw trans. We know the deal, right? I mean, same thing as the other 3. So I'm going to name this first. There's 4 carbons in total. So yet again, it's another butene. All right, that's an ENE. And at carbon number 1, that is where my double bond is going to be located. So that double bond is closest to the right-hand side. That's where we're going to put the focus on. This is a 1-butene, or you can just call it butene, and people would understand that the 1 is present. So there's the name to that structure. And now I need to go through and I need to focus on drawing the cis or the trans form of the structure. So I'll focus on the carbon-carbon double bond. I know that these have to have the legs on them. That's where I start every time. The carbon to the left, that's this one, has a hydrogen on it. And just put it there, you know, whatever. It doesn't matter. And then the other group is this ethyl group, a CH2 and a CH3. Okay, so that takes care of the left-hand side. And on the right-hand side, I have a carbon, and there's 2 hydrogens that are on it, a hydrogen here and a hydrogen there. All right, so if I just double-check this, make sure I still have butene. I do. There's 1 carbon, 2 carbon, 3 carbon, 4 carbon in total. So 4 is the long chain, butene, and it's a 1-butene because my number 1 carbon is right there. So it's still a 1-butene. Didn't change anything up, and I shouldn't have. And now I need to compare to see if this is cis or trans. The left-handed carbon, I have a hydrogen that points up. The right-handed carbon, I have a hydrogen that points up. But wait a minute. I also have a hydrogen that points down. So here's the case where I can't really compare them clearly, can I? They're both hydrogens. It's on the same carbon, and because of that, this does not have a cis or a trans notation. There is no way that I can compare hydrogens on the right-hand side because there's 2 of them that are present. And if I flip those 2 hydrogens around, it gives me the same exact structure. And that is why this does not have a cis or trans notation. Because as it flips back and forth, I'm not changing the molecule. It's the same thing. In this version, hydrogens on top, hydrogens on the bottom. If I flipped it around, hydrogens on top, hydrogens on the bottom. So I cannot label this as cis or trans for that reason. Okay? All right. So that's where this video is going to stop. And in the next one, we're going to continue examples with these. All right. I know I'm wearing you out with examples, but I think that you need them because I think that it will help confirm not only the lecture material that's presented here, but it's also going back and helping you confirm lecture material that was presented in Module 3. So it's wrapping both of these together because it's the same IUPAC rules, folks. That's why we do this. Okay. So in the next example, this is what we're going to see. It says, which of the following can exist as cis and trans? And then B says, for those compounds, draw and label them. So very similar to what we just did. So yet again, I'm going to tell you to do me a favor. That favor is write down this problem. Work these examples before you start the next video. And then when you start the next video, your answers are going to be in front of you. And then we're going to work through 1, 2, 3, and 4. And we're going to double check what you've done. So this way you can clearly see where your mistakes are at and you will know how to fix them. That's going to be the best way to learn organic. So in the next video, this is where we'll pick up problem number 7. So pause it if you need to. Jot down these structures, write down cis and trans if they have them, and then we'll come back and we'll compare our answers.